Bismillahirrahmanirrahim and Assalamu alaikum everyone. This is Mia Chanavid and I'm a 11th student at Jahan School Online Academy, and today I'm going to talk with climate change and cloud busting. So let's start. First we'll share screen with Annie. Yeah. Hey Annie, how are you? Today I'm gonna talk with you on climate change and cloud busting.
Hey Thera, that sounds like an important topic. Climate change is such a big deal and cloud rusting. That's a new one for me. What's got you interested in that? Is it something you've been reading about?
No, it's happening a lot in the world. Here in Pakistan and all that in other countries. So I just wanted to know the reasons, and also may I start asking the questions?
Absolutely, fire away. I'm all ears and ready for your questions. What do you want to know about climate change and cloud rusting?
Okay, first we'll talk about climate change, and then we'll start with the cloud rusting. So yeah, first one is that what is the difference between weather and climate?
Great.
Okay, so the question was, what is the difference between weather and climate change?
I'm sorry, I don't know where you are asking about. Can you ask that again but include where you want the weather for?
Talk on what is the difference between weather and climate.
Got it, here we go. Weather refers to the short-term atmospheric conditions in a specific place at a specific time. It includes things like humidity, precipitation, cloudiness, visibility, and wind. For example, if you step outside and it's sunny and warm, that's the weather that day. Weather can change quickly, so you might have a sunny morning but a rainy afternoon. On the other hand, climate is the long-term average weather patterns over an extended period, usually 30 years or more, in a particular region. It helps us understand what the weather is typically like in that area. For instance, a region might have a tropical climate, which means it's generally warm and wet, or a desert climate, which is dry and hot. In essence, weather is like a snapshot of what's happening right now, while climate is more like a movie that shows the trends and patterns over time. Understanding the difference is crucial, especially when discussing climate change, which refers to significant changes in global temperatures and weather patterns over time. So, while weather can change from day to day, climate takes a much longer view. Does that help clarify things? I could go on about how climate affects ecosystems and human life, but I'll pause here. What do you think? Awesome, Ixo. Building on that, let's talk about how climate affects ecosystems and human life. Climate plays a huge role in shaping the environment. Different climates support different types of ecosystems. For example, tropical rainforests thrive in warm, moist climates, while deserts are found in dry, hot climates. The plants and animals in these regions have adapted to their specific climates, which means changes in climate can disrupt these ecosystems. Now, when we talk about climate change, we're looking at how human activities like burning fossil fuels, deforestation, and industrial processes are causing the Earth's average temperatures to rise. This warming can lead to more extreme weather events, like hurricanes, droughts, and floods. It can also affect sea levels, which can result in coastal erosion and displacement of communities. For humans, climate change poses serious risks. It can impact food security, water availability, and health. For example, changing weather patterns can affect crop yields, leading to food shortages. Additionally, increased temperatures can exacerbate health issues, particularly for vulnerable populations. Communities around the world are adapting to these changes in various ways. Some are investing in renewable energy, improving infrastructure to withstand extreme weather, and promoting sustainable practices to mitigate the effects of climate change. It's a complex and urgent issue, and understanding the difference between weather and climate is essential for tackling these challenges. There's so much more we could explore, like the role of policy and community action in addressing climate change. What do you think? Any specific aspects you're curious about? I'm glad you're enjoying it. Let's dive deeper. One important aspect of climate change is its impact on biodiversity. As temperatures rise and weather patterns shift, many species struggle to adapt. Some may migrate to cooler areas, while others may face extinction if they can't find suitable habitats. This loss of biodiversity can disrupt ecosystems.
Oh, and he's disconnected. So let's try again. So yeah, the next question was, why does the weather change every day?
I'm sorry. Absolutely so. Why does the weather change every day? It's a mix of several factors. Atmospheric pressure. The air around us is always moving. High pressure systems bring clear skies and calm weather, while low pressure systems can lead to clouds and storms. Think of it like a dance party. When the music changes, the vibe shifts. Toward temperature, the sun heats it unevenly. Areas near the equator get more sunlight, while polar regions receive less. This difference creates temperature variations that influence wind patterns and weather systems. 3. Humidity. Moisture in the air can change rapidly. When warm air rises, it cools and condenses into clouds or rain. It's like when you're boiling water and things are changing. 4. Wind patterns. Winds are like the Earth's highways, moving air masses around. They can bring warm air from the tropics or cold air from the poles, causing shifts in weather. 5. Geography. Mountains, oceans, and cities all influence local weather. Mountains can block or redirect winds, and oceans can moderate temperatures. It's like having different rooms in a house. Each has its own vibe. So every day these factors interact in unique ways, leading to the ever-changing weather we experience. It's a beautiful, chaotic dance of nature. What do you think? Pretty cool how everything's connected, right? Gotta chill, let's dive deeper into some specific weather phenomena. 6. Fronts. These are boundaries between different air masses. When a warm air mass meets a cold air mass, it can create a front. Warm fronts often bring gentle rain, while cold fronts can lead to thunderstorms. It's like two friends meeting up. Sometimes it's a calm chat, and other times it gets a bit heated. 7. Seasons. The tilt of the Earth's axis causes seasons to change. As the Earth orbits the sun, different parts receive varying amounts of sunlight, leading to seasonal weather patterns. Think of it like a big cosmic dance where everyone gets their turn. Ice token currents. The oceans play a huge role in weather. Warm ocean currents can raise temperatures in coastal areas, while cold currents can cool them down. It's like the ocean is sending out to the atmosphere for a party. 9. Climate change. Over time, human activities have influenced weather patterns. Increased greenhouse gases trap heat in the atmosphere, leading to extreme weather events. It's a reminder of how interconnected everything is. Our actions can ripple through the environment. 10. Local factors. Things like urban heatlands, where cities are warmer than surrounding areas, can also affect weather. Buildings and asphalt absorb heat, creating mini climates. It's like when you're in a crowded room and everyone's feeling the heat. In summary, daily weather changes are a result of a complex interplay of atmospheric conditions, temperature variations, geographic factors, and even human influence. It's a dynamic system that keeps us on our toes. Hope that paints a clearer picture of why our weather is always changing. Isn't it fascinating?
Yeah, this one is fascinating. That's all. That's so great. So, what makes some places hot and some cold, and what is the atmosphere made of?
Great questions. Let's break it down. ONA temperature differences. The main reason some places are hot and others are cold is due to the sun's rays hitting angles. Areas near the equator receive direct sunlight year-round, making them warm. In contrast, places near the poles get sunlight at a slant, spreading the energy over a larger area, which keeps them cooler. It's like a warm blanket versus a thin sheet. One keeps you cozy, while the other might leave you chilly. To elevation, higher altitudes tend to be cooler. Think about climbing a mountain. It's often colder at the top than at the base. This is because the air gets thinner and can't hold heat as well. Free ocean currents. Warm and cold ocean currents can also affect nearby land temperatures. For example, the Gulf Stream warms parts of Europe, while cold currents can chill coastal areas. Far land sweater. Water heats and cools more slowly than land. Areas near large bodies of water tend to have milder temperatures, while inland areas can experience more extreme heat or cold. It's like how a hot cup of tea cools down slowly compared to a hot plate. Now about the atmosphere. The atmosphere is made up of several layers and consists mainly of nitrogen, about 78%, and oxygen, about 21%, with trace amounts of other gases like carbon dioxide, argon, and water vapor. It's like a big invisible blanket surrounding the Earth, protecting us and keeping everything in balance. It plays a crucial role in weather and climate, acting as a barrier to harmful solar radiation and helping to regulate temperatures. It's pretty amazing how it all works together, isn't it? Want to explore this more, or if there's something else you're curious about? You're welcome. I'm glad you found it interesting. If you have more questions or absolutely, let's dive deeper into some fun aspects of the atmosphere and temperature variations. ONI layers of the atmosphere. The atmosphere has several layers, each with distinct characteristics. Troposphere. This is where we live and where weather occurs. It extends from the Earth's surface up to about 815 kilometers, 59 miles high. It gets cooler as you go up. Stratosphere. Above the troposphere, this layer contains the ozone layer, which absorbs and scatters ultraviolet. It's warmer here because of the ozone. Mesosphere. This layer is where meteors burn up upon entering the atmosphere. It gets cooler again as you rise higher. Thermosphere. Here, temperatures can soar to thousands of degrees Celsius. It's where the auroras happen, and it's also where the International Space Station orbits. Exosphere. This is the outer sphere gradually fades into space. It's mostly empty. Tall weather patterns. Weather is influenced by larger systems like jet streams. These are fast-flowing air currents high in the atmosphere that can influence weather patterns. They can help steer storms and affect temperatures. Cyclones and anticyclones. These are large systems of winds that can bring different weather. Cyclones are associated with low pressure and stormy weather, while anticyclones are high pressure and usually bring clear skies. 3. Microclimates. Within larger climate zones, you can find microclimates, small areas with different weather conditions. For example, a city might be warmer than its surrounding countryside due to buildings and human activity. It's like having a cozy nook in a big room. Climate zones. The Earth is divided into different climate zones based on temperature and precipitation. You have tropical, arid, desert, temperate, polar, and more. Each zone has its own unique weather patterns and ecosystems. 5. Impact of human activity. Human activities like deforestation and burning fossil fuels can alter local and global climates. This can lead to more extreme weather events, rising sea levels, and changes in ecosystems. That we're all connected to our environment. I could go on forever. The atmosphere is such a rich and complex system. What do you think? Anything specific you want to explore more? I'm so glad you're enjoying it. Let's dive even deeper into some more fascinating aspects. One greenhouse effect. This is a natural process that warms the Earth. Certain gases in the atmosphere, like carbon dioxide and methane, trap heat from the sun. It's like a cozy blanket keeping the planet warm enough to support life. However, human activities have increased these gases, enhancing the greenhouse effect and leading to global warming. It's a bit like turning up the heat too high, things can get uncomfortable. To away their fronts. Let's explore fronts a bit more. When warm air rises over cold air, it creates a warm front, leading to gradual temperature increases and steady rain. In contrast, when cold air pushes under warm air, it forms a cold front, often resulting in thunderstorms and sudden temperature drops. It's like a surprise party. Sometimes it's calm and sometimes it's a whirlwind of excitement. 3. Humidity and precipitation. Humidity is the amount of moisture in the air. High humidity can make temperatures feel warmer, while low humidity can make it feel cooler. When the air gets saturated with moisture, it leads to precipitation, rain, snow, sleet, or hail. It's nature's way of keeping it balanced. Storms. Let's talk about different types of storms. Thunderstorms. These can form when warm, moist air rises rapidly. They can produce heavy rain, lightning, and even tornadoes. Hurricanes. These are powerful tropical storms that form. Ha, I love your playful spirit. Let's keep the conversation rolling. So let's talk about how different factors interact in the atmosphere. It's like a big dance party, and everyone has their own moves. Oceanic and atmosphere interaction. The oceans and atmosphere are in constant communication. Ocean currents influence weather patterns, and in return, the atmosphere affects ocean temperature. This dance can lead to phenomena like El Niño and La Niña, which can dramatically alter weather across the globe. It's like they are partners in a tango, sometimes pulling together and sometimes pushing apart. Toy topography. The shape of the land can create unique weather patterns. Mountains can block moist air, leading to rain on one side and dry conditions on the other, a phenomenon known as the rain shadow effect. It's like a natural barrier that decides who gets the party favors. 3. Urban heat islands. Cities can be warmer than surrounding rural areas due to human activities and structures. This phenomenon, called the urban heat island effect, can lead to higher energy consumption for cooling and increased air pollution. It's like a cozy blanket that sometimes gets too warm. 4. Climate adaptation. As climate change affects weather patterns, communities are finding ways to adapt. This can include building better infrastructure to withstand storms, trees to provide shade, or creating green spaces to cool urban areas. It's all about finding balance and resilience. 5. Importance of education. Understanding these. Historia.
So the next question is that how do clouds form in the sky?
Great question. Clouds are like nature's fluffy art in the sky. I'm glad you're curious. What else would you like to know about clouds or weather? Or maybe you want to explore a different topic. Absolutely, there's clouds form in the sky. Only evaporation. Water from oceans, lakes, and rivers turns into vapor due to heat from the sun. This warm, moist air rises into the atmosphere. 3. Cooling. As it rises, the air cools down. 4. Condensation. The water vapor condenses into tiny droplets around particles like dust, forming clouds. 5. Cloud formation. When enough droplets gather, they create visible clouds. And voila, that's how clouds come to be. Do you have any other questions or topics you want to explore?
Next question is that why do we need air?
Great question. Air is super important for life on Earth. Here's why we needed own breathing. Air contains oxygen, which is essential for humans and animals to breathe. We need oxygen to produce energy in our bodies. To photosynthesis, plants take in carbon dioxide from the air and use it, along with sunlight, to produce oxygen and food through photosynthesis. So plants help create the oxygen we breathe. 3. Temperature regulation. The atmosphere helps regulate the Earth's temperature. It traps heat from the sun, keeping our planet warm enough to support life. Without it, Earth would be too cold. Foul protection from harmful radiation. The atmosphere acts like a shield, protecting us from harmful solar radiation and meteoroids. The ozone layer, a part of the atmosphere, absorbs most of the sun's harmful UV rays. 5. Weather and climate. Air plays a vital role in weather patterns and climate. It helps distribute heat and moisture around the planet, influencing everything from rain to wind. 6. Sound transmission. Air carries sound waves, allowing us to communicate and enjoy music and nature sounds. So without air, life as we know it would be impossible. Isn't that fascinating? Do you have more questions about air, or is there something else you'd like to chat about?
Question is that what does climate change mean and how is climate different from other weathers?
I'm sorry, I don't know where you are asking about. Can you ask that again but include where you want the weather? Great questions. Let's break it down. ONE global warming. This refers to the long-term increase in Earth's average surface temperature due to human activities, primarily the burning of fossil fuels, which releases greenhouse gases like carbon dioxide. These gases trap heat in the atmosphere, leading to a warming effect. Climate change. This is a broader term that encompasses global warming but also includes other changes in climate patterns. It refers to significant changes in temperature, precipitation, wind patterns, and other elements of the Earth's climate system over an extended period. Climate change can lead to extreme weather events, rising sea levels, and shifts in ecosystems. Difference from weather. Weather is the short-term state of the atmosphere at a specific place, like a sunny day or afternoon. Climate, on the other hand, is the average weather conditions in a region over a long period, typically 30 years or more. So while weather can change quickly, climate changes occur more gradually. Isn't it interesting how interconnected everything is? If you have more questions, want to dive deeper into any of these, awesome, let's dive deep. Absolutely, let's dive deeper. Owning effects of global warming. Melting ice caps. As temperatures rise, polar regions and glaciers are melting, contributing to rising sea levels. Extreme weather. We're seeing more frequent and severe weather events like hurricanes, droughts, and rainfall. Ecosystem disruption. Many plants and animals are struggling to adapt to changing climates, lead shifts in habitats, and, in some cases, extinction. Impact. Fossil fuels. The burning of coal, oil, and natural gas for energy is a major contributor to greenhouse gas emissions. Deforestation. Cutting down forests reduces the number of trees that can absorb carbon dioxide, making climate change worse. Agriculture. Farming practices can release greenhouse gases, especially livestock production, which emits methane. 3 solutions. Renewable energy. Switching to solar, wind, and hydroelectric power can reduce our reliance on fossil fuels. Energy efficiency. Using energy-efficient appliances and practices can lower energy consumption. Reforestation. Planting trees can help absorb carbon dioxide from the atmosphere. Climate policy. Governments implement policies to reduce emissions and promote sustainable practices. For global cooperation, climate change is a global issue requiring countries to work together. Agreements like the Paris Agreement aim at global warming and encourage nations to reduce their carbon footprints. It's a complex topic, but understanding it is crucial for our future. What specific areas do you want to explore more? Maybe solution effects or something else. Let's keep diving.
Thank you so much for the explanations. I really enjoyed that. I hope I learned a lot and I'll remember that. Thank you so much for helping me out. Bye. Allah Hafiz.
You're so welcome. I'm glad you enjoyed it and learned a lot.